Okay, so I'll just be talking through the handout, the things that we need to know about audiograms and how they connect with the equal loudness contours and the temporary threshold shift. Okay, so here under Roman numeral number 1 kind of summarizes the important things to know for our class about conductive hearing loss and sensorineural loss. And a reminder that presbycusis is the normal high frequency hearing loss that accompanies normal aging effects. Okay, so the first thing to do is to know how to read and interpret an audiogram and identify different kinds of hearing loss. So, for example, this person at 250 hertz, this X right here that I'm putting in purple, that is on the 0 line. So that is what we refer to as normal hearing threshold. So they have normal hearing at 0 or at 250 hertz. So the frequencies are going across the top. Okay. But this X right here, they have is on the 10 decibel line. Okay. And so that means that there is 10 decibels of loss relative to normal hearing. So they need 10 decibels more of input level to the ear. Okay. Now, this question has you compare a few things about these couple of audiograms. So I'm going to talk through each of those answers now. So number one, the right ear hears 1 kilohertz better than the left. So just so we are clear, 1 kilohertz is 1,000 hertz. Okay, so we're looking at the 1,000 hertz line on both of them. So if we follow them down, I'll put these ones in orange. Okay, we see that for the right ear, there is 0 decibels of loss. And for the left ear, there is 10 decibels of loss. Okay, so 10 dB loss for left ear is more loss than 0 dB for right ear. Okay, so that means the right ear hears better, so A is a true statement. Okay, B is that same frequency, and it basically says the right ear shows 10 dB of loss at 1 kilohertz, but we just decided that it was 0 dB, so that statement is false. Okay. Overall, both ears show some signs of presbycusis. So you see this kind of decrease with hearing at high frequencies. I didn't go through the zeros, but kind of this kind of decrease thing going on. Those are examples of presbycusis. Okay, so that is a true statement. That's kind of the normal high frequency loss associated with just a lifetime of noise exposure. Can be worse if you have a career where you're exposed to lots of noise. Okay. Overall, the right ear hears better than the left ear. That is also true because you can see here on the left ear, some of these are a little bit lower than over here where they're, right at the 0 still. The high frequency stuff is very similar, but in that kind of 500 and 1,000 hertz range, the right ear does hear better. Okay, so the bigger the number here, that is equal to more loss. Okay, and this 0 line here is what we call normal threshold. Okay. Now we get into this idea of a temporary threshold shift and trying to relate the audiograms to the equal loudness contours. So this is a big key here, okay? The plus thresholds on the loudness level contours equal the 0 dB line on the audiogram. Okay, that's the important thing. Okay, so if I draw my audiogram here, and I have my different frequencies coming down, So this would be like 125 hertz, 250 hertz, 500 hertz, 1000 hertz, etc. Okay, so that's the frequency axis. Then this is the decibels. This is the loss. The zero line there corresponds with these pluses. So this plus right here that is at 42 decibels and 125 hertz corresponds to this plus right here. Okay, so the 0 on the audiogram at 125 hertz means that your sound level meter would read 42 decibels. Okay, similarly at 250, this orange one, that plus is at 22 decibels and 250 hertz, and so forth. Okay, that would correspond with this, the 0 point right there. This blue, I'll make this one blue, I'll just do one more. That's at approximately 10 decibels and 500 hertz. That would go with that point right there. Okay, and so on. Okay, so if someone has a 10 dB, okay, so that means that they have, let's say, an X right here on their audiogram. That would mean, well, actually, let me do 500 because of the way these questions work out. Okay, so if someone's X on their audiogram sat right there at 10, that would mean you would come over, that means that it's 10 dB of loss at 500 hertz. That means they would need to hear a sound 10 decibels louder in the sound pressure level. So you come over here, you start at the plus, and then you would add 10 decibels. Okay, oops. And that dark green X on the audiogram over there corresponds to this dark green X right here. So 10 more decibels are needed for the person to hear than what they saw. Okay, if this was instead all the way down here, say at 40, that means that they would need 40 decibels extra, which means that you would go up 10, 20, 30, 40 decibels to find out that the minimum level they could hear, because they have 40 dB of loss relative to the plus, would then be 50 decibels. Okay, so let's go ahead and do these two questions. Consider a person that had normal hearing. Okay, how do you dissect this sentence? Okay, let's do purple. Normal hearing prior to a noise exposure. Okay, so that is the 0 line on the audiogram. That's what we mean by normal hearing. Okay. Then they have some noise exposure event, and after that, okay, the lowest sound pressure level that can be heard, okay, so when you hear see sound pressure level, now you're thinking vertical axis on the equal loudness contours. Okay. The lowest SPL they can detect at 250 hertz is 50 decibels. So let's draw that. So 250 hertz, okay, 50 decibels is the lowest they can hear. They can't hear the plus at 22 decibels at 250 hertz. They can only hear if the stimulus is 50 decibels. Okay, and then you're wondering, what is the, so that was the 50 decibels. So the vertical axis here. All right, and then this last part is saying, where does that temporary threshold shift? Okay, the temporary threshold shift is the difference between normal hearing and the new hearing level. Okay. So that difference will be right here. So 50 decibels minus 22 decibels. Okay, will give us a temporary threshold shift of 28 decibels. And that means that this blue circle here, right here, corresponds to a 28 decibel loss over here on the audiogram. Okay. That temporary threshold shift from normal being 28 decibels. Okay, now let's try the next one. The next ones we're going backwards. We're starting with the audiogram and then trying to figure out the levels. So let's dissect this sentence again. What color have I not used yet? Dark purple. Okay, let's see. First, we have normal hearing prior to the exposure. Okay, so that means that originally their X or O was right there at the 0. Noise event, temporary threshold shift at 125 hertz is 30 decibels. So that means that they're sitting right there on their audiogram. Okay, and then you're being asked, what is the lowest sound level? Okay, so this again is over here on this vertical axis. So having this circle on the audiogram at 30, at 125 hertz, means that the person went in for an audio hearing test and they put in, basically they put in the 42 decibels at 125 hertz and they couldn't hear it. And so they put in 52 and then 62 and they still couldn't hear it. And it wasn't until they got to 72, so 30 decibels higher than normal hearing, which is the pluses, that the person was able to sense it. So that is the lowest sound level in decibels they could detect would be 30 decibels plus 22 decibels. So the 30 decibel temporary threshold shift, okay, plus where the plus is, which is 22 decibels, means the lowest sound pressure level would be 52 decibels. Or no, sorry. Got that backwards. 42 decibels from the green here. Do my color coding better. 42 decibels is the plus at 125 hertz, okay? And so then if I add the 30 decibel shift to the 42, then I would get 72 decibels. Okay, so this is the level, and this guy here is the temporary threshold shift. So this is the temporary threshold shift. This is normal hearing threshold. And then this is the lowest SPL that can be heard. Whereas in the one before, we were told the lowest SPL. We had the normal level where the plus was, and then we were calculating the temporary threshold shift. So you can go either way, backwards or forwards on those. Okay, well, I hope that is helpful. Thank you.